Hello class, today we're going to be learning about 8.4 scientific notation. So, what is scientific notation? It is really just a way to represent really big numbers and really small numbers. So this first part here says, one way to write very small numbers like the thickness of a soap bubble, which you can imagine would be very, very small. Or very large numbers, like the number of stars in a galaxy, is to use powers of 10. So scientific notation is really a number that is written in this form, where n is the integer between 1 and 10. So really what I'm talking about here is if I had like 3 times 10 to the 17th, that's scientific notation. What is important to note is that this number, we'll say n, is only one digit placed to the left of the decimal point. Okay? And this little n here is representing an exponent. So I think the best part is to actually get into some examples. Standard form is really how we always represent numbers. So any numbers that we've worked up until this point, it's actually called standard form. So we have the number 325,000. Okay, how can I write this using scientific notation? Well, what am I going to do is I'm going to look at this number 3. That's going to be the number that's in front of the decimal point. We only have one number in front of that decimal point. So right there, right after that 3 is going to be the decimal point. And then I have to write down the 2 and the 5. And now it's going to be times 10 to the, and we have to figure out what this is. Okay, so if there was a decimal point here, how many place values, how many times would I move it to the right to get to the end of this? So let's count. We have 1, 2, 3, 4, 5. So it would be times 10 to the 5th. Now it works the opposite way with small numbers, okay? So this is currently where the decimal place is. This is where I want it to be. So scientific notation is going to be 5 point. And then there's no numbers after this 5, so that means that we don't have to put like 5 point something. It's just going to be 5 times 10 to the, and now this is going to be a negative. The reason why is because this is where we want the decimal point to be, right after this, let me change colors. Right after this 5 here, that's where we want it to be. So I am moving the decimal place to the left. 1, oops, let me try that again. Okay, 1, 2, 3, 4. I moved it 4 places to the left to get the actual number. So that would be 5 times 10 to the negative 4th. So really kind of a good tip is that if we have large numbers, you're going to have a positive exponent. If we have small numbers, you're going to have a negative exponent. So that's just a good way to remember it. All right, example 1, we're going to write the numbers in scientific notation. So this, right after the 7 is where we want the number to, the decimal place to be. So it's going to be 7.82 times 10 to that, and now let's figure it out. So we move it 1, 2, 3, 4, 5, 6 spots. All right, that was a large number, so I'm just double checking, is my exponent positive? Yes, it is. Okay, next, we want the decimal point to be after the 4, so it's going to be 4.01 times 10 to the, and now we have to figure it out. So it's 1, 2, 3. So it's going to be negative 3 because we moved it 3 to the left. And you can double check. This should be a negative number if this is a small number originally. Yes, it is. Okay, let's try letter C. This is where we want it to be, so it's going to be 8.99 times 10 to the, and let's see, times 10 to the 1, 2 power. And we're moving to the left, so it's a negative 2. Example 2, we're going to write the numbers in standard form. Remember, that's just like regular numbers, what we always write them as. So I'm going to start this by writing down our 3.89. Now I have to move it 9 spots to the right, the decimal point I'm talking about. So here's the decimal point. We're going to move it 9 to the right. 1, oh, it keeps wanting to make a straight line, sorry. Let's try that again. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now all of these little valleys, I'm going to put in a 0. So, if I want to write this more neatly, looks like we have 3 zeros. Here's another 3 zeros. I'm putting in commas here, after every 3 numbers. Okay, so that would be how I would write it. Okay, letter B. Notice that this is a negative number, so that means I move to the left. So if I write this original 9.097 and I move the decimal point 5 spots to the left. 1, oh boy, I don't want to draw a circle. Sorry about that. All right, 5 to the left. 1, 2, 3, 4, 5. We're going to fill in a 0 in all of those valleys. And we're also going to put a 0 in front here for a placeholder. So now we have 0.00009097. If I want to double check, this was originally a negative number. That's indicating a very small number, which it is there. Okay, letter C. So I'm going to write down the original. And I'm going to move it 7 spots to the right because it's positive. So 1, 2, 3, 4, 5, 6, 7. Fill in with zeros. Okay, and I'm going to go through and I'm going to put a comma after every 3 numbers just so that I can clearly see what my actual number is. Again, this was a positive exponent, so I should have a big number right there, which I do. Okay, example 3. Now we need to order the following numbers from least to greatest. So there's a couple of ways that we can think about this. Okay, one of those ways being if we write them all in scientific notation, then we'll be able to quickly compare. So I'm noticing that the first and the third number here are already written in scientific. Let's change the second one. So this is where I'm going to want the decimal point to be. So I'm going to move it 1, 2, 3, 4 spaces. So that's going to be 4 times 10 to the negative 4th. And we would have to move it 4 to the left to get this original number, so that's why it's negative. Okay, so now what I can do to just quickly compare is the first number is times 10 to the negative 4th. The second number is times 10 to the negative 4th. And the fifth number is times 10 to the negative 5th. So this one looks different. Okay, if I think about it, this third number here, that times 10 to the negative 5th, that means I'm going to move the decimal point one more space to make it even smaller. The more negative, I should say, the exponent, the smaller the number is. So this one is going to be 2.8 times 10 to the negative 5th. That's our smallest number. Okay, so now we need to figure out, would it be the first one or the second number first? Well, this one is 3.2, and that is smaller than the number 4. So 3.2 times 10 to the negative 4th would be the next smallest. And then I'm going to write the numbers as they originally appear. So instead of writing 4 times 10 to the negative 4th, I'm going to write this original number, which is 0.0004. Okay, Okay, and that is one method for writing them from least to greatest. Now there is another way that we could do this, and that would be to change them all into standard form. So I'm noticing that the second and the third numbers in letter B are already in standard form. Let's change the first number into standard form. So I need to move that decimal point 5 spaces to the right. 2, 3, 4, 5. Fill in with zeros. So that is really the number 175,000. Okay, now I can quickly compare. Okay, let's see. I'm noticing that this is the largest number. We've got something in the millions. So I'll write that on the very right. That's our largest number. Okay, so we're done with that one. Now we have to decide between these two. Well, 175,000 is smaller than 225. So it's going to be 175,000 first, which I want to write my original, how it was originally represented, which was 1.75 times 10 to the 5th. So that was the smallest, and then 225,000, and then my 1,740,000. Okay, flipping over to the back side. I have a note there that says you can use exponent properties when working with numbers written in scientific notation. So the exponent properties, that's what we did so far in Chapter 8. Okay, so example 4, evaluate each expression, write your answers in scientific notation. Okay, so what I'm talking about with the exponent properties is really, you're going to be taking like times 10 to the negative 4th and times 10 to the negative 5th, and you can actually combine those. Okay, so let me just show you here. So we're going to take these two numbers that are in front, this 5.6 and 1.4. So we're going to actually do that math, 5.6 times 1.4. Okay, then we are going to take these two, and I'm going to write it out first before I actually compute this. So times 10 to the negative 4th times 10 to the negative 5th. Now if you remember, if we have powers with the same base that are being multiplied together, you add the exponents. So if I were to take these two numbers and add the exponents, we would have times 10 to the negative 9th power. And then if I take a calculator and do 5.6 times 1.4, I should get 7.84. I just want to double check, is this in scientific notation? And yes, it is. Yep. Okay, in letter B, we've got an exponent here outside the parentheses. So really what this is saying is I distribute that exponent through. So it's like saying 3.2 to the 3rd power times 10 squared to the 3rd power. Okay, if I take a calculator, 3.2 to the 3rd power is 32.768. Now, 10 squared to the 3rd power, if you remember, what happens here is I multiply those two exponents. So this will actually become times 10 to the 6th power. Now this is not in scientific notation. Why is it not? Well, because of this. I have two numbers in front of the decimal point. In scientific notation, I can only have one number. So I need to move this one space this way. So it's going to be 3.2768 times 10 to the, now because I moved this decimal point over 1 right here, I need to change this, okay? I'm going to change it, I moved it one more over, so this is going to be times 10 to the 7th. And if you think about it, if I took this number right here and moved this 7 spaces to the right, oops, I didn't count, 1, 2, 3, 4, 5, 6, 7, I can double check, is this number the same is if I took this and moved it 6 spots. So I can try that. 32.768 and moving it 6 spaces. 1, 2, 3, 4, 5, 6. If I fill that in with zeros, yes, these two are both the same. So that means that this is my answer. That's just a quick check because sometimes I personally forget if I move this decimal point one more over, do I need to change this exponent to a 6, or excuse me, to a 5 or to a 7? Sometimes it's hard to remember. So this strategy will help you out with that. Okay, let's do letter C. Very similar to letter B. We're going to distribute that through. So we have 2.01 squared times 10 to the negative 7th squared. 2.01 squared is 4.0401 using a calculator. And then we have times 10 to the, and it's going to be negative 14. The reason it's negative 14 is because you multiply that negative 7 with the 2. Okay, letter D. Now we are going to be dividing. A fraction is the same thing as divide. So I'm going to divide 3.5 by 1.75. If I do that, I get the number 2. Now that's going to be times 10 to the. Now here we have 2 powers with the same base, and we are dividing. So if you remember, we subtract the exponents. So we have negative 3 minus a negative 5. Minus a negative turns to a plus, so negative 3 plus 5 is positive 2. So it's going to be 2 times 10 to the second power. And our last example, letter E, very similar to the last one. We're going to divide these two. 4.8 divided by 6 is 0.8. And then we've got 10 to the negative 4 divided by 10 to the negative 4. Okay, if you think about that, any number divided by itself cancels out and it leaves you with the number 1. So this is like 0.8 times 1, which is really just 0.8. Now, in all honesty, I would be fine if you keep this as your answer. However, our directions actually do say to write in scientific notation. Currently, this is not scientific notation. So scientific notation, just a reminder, is when I have one number to the left of the decimal point. So my decimal point has to be here. So it's going to be 8 times 10 to the, and if you think about it, if this is what my number should be, 0.8, and here's where my decimal point is, I have to really move that decimal point one spot to the left in order for it to represent 0.8. So my answer would be 8 times 10 to the negative 1. Okay, remember, you guys are so amazing. You're doing